The Mi-28 is a Russian all-weather, day-night, military tandem, two-seat anti-armor attack helicopter. It is a dedicated attack helicopter with no intended secondary transport capability, better optimized than the Mi-24 for the role. It carries a single gun in an undernose barbette, plus external loads carried on pylons beneath stub wings. Development, origins, in 1972. Following completion of the Mi-24, development began on a unique attack helicopter with transport capability. The new design had a reduced transport capability and omitted the cabin, to provide better overall performance and higher top speed. Improved performance was important for its intended role fighting against tanks and enemy helicopters and covering helicopter landing operations. Initially, many different designs were considered, including an unconventional project with two main rotors, placed with engines on tips of wings, and with an additional pusher propeller on the tail. In 1977, a preliminary design was chosen, in a classic single-rotor layout. It lost its similarity to the Mi-24, and even the canopies were smaller, with flat surfaces. Design work on the Mi-28 began under Marat Tishchenko in 1980. In 1981, a design and a mock-up were accepted. The prototype was first flown on November 10, 1982. The second prototype was completed in 1983. In 1984, the Mi-28 completed the first stage of state trials, but in October 1984 the Soviet Air Force chose the more advanced Kamov Kar-50 as the new anti-tank helicopter. The Mi-28 development was continued, but given lower priority. In December 1987 Mi-28 production in Rosvital in Rostov-on-Don was approved. An early production Mi-24 was fitted with an air data boom as an early test for the Mi-28's technologies. Later, a few Mi-24DS were fitted up with a Mi-28 radome mount for testing the sighting flight navigational complex's abilities, and others had redesigned fuselages that closely resemble the future Mi-28, but with rounded cockpits. In January 1988 the first Mi-28A prototype flew. It was fitted with more powerful engines and an X-type tail rotor instead of the three-blade version. The Mi-28A debuted at the Paris Air Show in June 1989. In 1991 the second Mi-28A was completed. The Mi-28A program was cancelled in 1993 because it was deemed uncompetitive with the Kar-50, and in particular, it was not all-weather capable. The Mi-28N was unveiled in 1995, the N designation meaning night. The prototype first flew on November 14, 1996. The most significant feature is a radar in a round cover above the main rotor, similar to that of the American AH-64D Apache Longbow. Mi-28N also has improved tour vision and an aiming device under the nose, including a TV camera and FLIR. Due to funding problems, development was interrupted. A second prototype with an improved rotor design was unveiled in March 2004 at Rosvital. Changes in the military situation after the Cold War made specialized anti-tank helicopters less useful. The advantages of the Mi-28N, like all-weather actionability, lower cost, and similarity to the Mi-24, have become important. In 2003, the head of Russian Air Forces stated that the Mi-28N and Kar-50 attack helicopters will become the standard Russian attack helicopter. The first serial Mi-28N was delivered to the Army on June 5, 2006. By 2015, 67 miles-28 nanoseconds are planned to be purchased, when the Mi-24 is to be completely replaced. MIL also developed an export variant of the Mi-28N, designated Mi-28NE, and a simpler day helicopter variant, the Mi-28D, based on the Mi-28N design, but without radar and FLIR. Mi-40, the Mi-40 was a projected utility version of the Mi-28, first initiated in 1983, announced in 1992 and shown at the Moscow Air Show in 1993. It was primarily intended for the aerial infantry fighting vehicle category as a successor to the Mi-24 and Mi-8 assault helicopters. It was planned to use two 1,863 kW Klimoff TV3-117 turboshaft engines, 4-blade main rotor, 4-blade Delta H tail rotor, and retractable tricycle-type landing gear. It was expected to weigh 11,000–12,000 kg and estimated to attain a 3,300 m ceiling, a 314 km/h maximum speed and a 260 km/h cruise speed. Specifications required the functioning in day, night and poor weather as well as carrying 8 soldiers, 8 stretchers or large external loads. An emphasis was placed on survivability with a focus on redundancy, IR suppression and special shock absorbers for the crew to increase the maximum safe crash velocity. The design incorporated a 23-ohm cannon for defense in the forward hemisphere and a 12.7-ohm machine gun for defense in the rear. Fuselage fairings containing fuel would replace stub wings with missiles mounted above on special hardpoints. Its design borrowed much from the Mi-28 developed over the previous 2 years, and would itself be replaced after a year by the Mi-42 project. Although the Mi-40 design would be resurrected for a short period in the 1990s, with optimization studies being completed, it did not reach the prototype stage. Mi-28 nanometers. Russia will develop and test a prototype Mi-28 with 5th-generation attack helicopter features by 2017. Called the Mi-28 nanometers, it has been in development since 2008. Specific characteristics are not known, but may include a low radar signature, extended range, advanced weapons control systems, air-to-air engagement capability, and increased top speed of 600 km/h. Design. The Mi-28 is a new generation attack helicopter that functions as an air-to-air and air-to-ground partner for the Mi-24 Hind and Ka-50 Hocum. The 5-blade main rotor is mounted above the body midsection, and short, wide, tapered, weapon-carrying wings are mounted to the rear of body midsection. 2 turboshaft engines in pods are mounted alongside the top of the fuselage with downturned exhausts. The fuselage is slender and tapers to the tail boom and nose. It features a tandem, stepped-up cockpits and a cannon mounted beneath the belly, with non-retractable tricycle tailwheel-type landing gear. This energy-absorbing landing gear and seats protect the crew in a crash landing or in a low-altitude vertical fall. The crew is able to survive a vertical fall of up to 12 ams. The Mi-28 has a fully armored cabin, including the windshield, which withstands impact by 7.62 and 12.7 mm bullets and 20 mm shell fragments. The helicopter design is based on the conventional pod and boom configuration, with a tail rotor. The main rotor head has elastomeric bearings and the main rotor blades are made from composite materials. The tail rotor is designed on a biplane configuration, with independently controlled X-shaped blades. A new design of all-plastic rotor blades, which can sustain hits from 30 mm shells, has been installed on the Knight Havoc Mi-28N helicopter. Havoc is equipped with 2 heavily armored cockpits, a windshield able to withstand hits from 12.7 Euro 14.5 ohm caliber bullets, in-nose electronics, and a narrow X-tail rotor, with reduced noise characteristics. It is powered by 2 2,200 HP isotope TV3-117 VM turboshaft engines. While the Mi-28 is not intended for use as a transport, it does have a small passenger compartment capable of carrying 3 people. The planned purpose of this is to enable the rescue of downed helicopter crews. The Mi-28N features a helmet-mounted display for the pilot. The pilot would designate targets for the navigator weapons officer, who proceeds to fire the weapons required to fulfill that particular task. The integrated surveillance and fire control system has 2 optical channels providing wide and narrow fields of view, a narrow field of view optical television channel, and laser rangefinder. The system can move within 110 degrees in azimuth and from +13 to -40 degrees in elevation. The Knight Havoc helicopter retains most of the structural design of the Mi-28. The main difference is the installation of an integrated electronic combat system. Other modifications include, new main gearbox for transmitting higher power to the rotor. new high-efficiency blades with swept-shaped tips, and an engine fuel injection control. The pilot uses a helmet-mounted target designator, which allocates the target to the navigator's surveillance and fire control system. The navigator weapons officer is then able to deploy guided weapons or guns against the target. The targeting system follows the direction of the pilot's eyes. Armament: the Mi-28 is equipped with a chin-mounted 30mm Shipinov 2A42 autocannon. The cannon is select-fire, and has a dual feed, which allows for a cyclic rate of fire between 200 rounds per minute to 550 rounds per minute. Its effective range varies from 1,500 meters for ground vehicles to 2,500 meters for air targets. Rounds from high-explosive incendiary to armor-piercing discarding sabot can be used. Stated penetration for the 3UBR-8 is 25 ohm/HA at 1,500 meters. One common Mi-28 armament are a pair of 8 Attribution missile racks along with 2 B-13L rocket pods, each able to carry 5 S-13 rockets. Other rocket options include 2 B-8 rocket pods, each able to carry up to 20 S-8 rockets. There are 4 variants of the Attribution missile for different tasks. The 9M120 tandem high-explosive anti-tank warhead variant is used against tanks fitted with explosive reactive armor. Its penetrative ability is stated at 800 on rolled homogeneous armor. The 9M120F thermobaric variant is used against infantry, buildings, bunkers, and caves. The 9M120O expanding rod warhead variant is used against other helicopters. All the variants have a range of 6 km. The 9M120M improved version has a longer range and better penetration. All of the variants use SACLOS missile guidance. The S-8 and S-13 rockets used by the Mi-28 are usually unguided. In the most common configuration, one can expect 40 S-8 rockets or 10 S-13 rockets. Both rockets have their variants, from heat warheads to a thermobaric warhead. The S-8 has a shorter range and smaller warhead than the S-13, but compensates with numbers. Currently, the Russian Air Force are upgrading their S-8 and S-13 rockets to laser-guided missiles with the proposed Ugroza system. Rockets upgraded under Ugroza would receive designations S-8 Kur and S-13 Kur, respectively. Operational history: Russia. The Russian Army received the first Mi-28 prototypes for testing in 2004. It received the first serial production Mi-28N in 2006, which then joined 2 prototype helicopters for Army trials. The aircraft entered service in 2006. It has entered service under the name of Night Hunter. A squadron of Mi-28 nanoseconds from Havoc took part in a joint Army exercise in Belarus in June 2006. The Russian Air Force had 24 Mi-28s in service in February 2011. On February 15, 2011, a Mi-28 crashed in the southern Russian region of Stavropol. One of the pilots later died in the hospital. The Russian Defense Ministry will procure up to 60 Mi-28 UB training versions by 2020. The version will speed up and improve pilot training. 4 to 6 Mi-28 UBs will be purchased for every unit that operates the Mi-28N. The Mi-28N is to replace the Mi-24 Hind in the Russian Armed Forces by 2015. Kenya: in late 2011, Kenya began the process of acquiring 16 Mi-28 ground attack helicopters for its Embakasi-based 50th Air Cavalry Division. The attack helicopters were acquired after senior military officers made several visits to Russia. The helicopter gunships were delivered to the 50th Air Cavalry Division in Kenya on January 3, 2012, from the Russian state-owned corporation Rosoboronexport, which is an intermediary for all imports and exports of military-related hardware. Iraq: in October 2012, it was reported that Russia and Iraq may sign a $4.2 euro $5.0 billion weapons contract, including 30 Mi-28N helicopters. The deal was confirmed on October 9. The deal was reportedly cancelled due to Iraqi concerns of corruption, but that concern was addressed, and the Iraqi defense minister stated that the deal is going ahead. Despite early complications, all parts of the $4.2 billion contracts were signed, and are being executed. The first contract for 10 Mi-28NE helicopters for Iraq will begin delivery in September 2013. A batch of 13 Mi-28NE helicopters was delivered in January 2014. India. The Indian military asked for a modified prototype of Mi-28 fitted with French and Belgian avionics. Russian manufacturers were discussing how to meet these requirements. In late October 2011, it was reported that the American AH-64D had emerged as the frontrunner ahead of the Mi-28N to fill a requirement for 22 attack helicopters. Algeria. In June 2010, Algeria was expected to place an order for 42 Mi-28NE helicopters. Venezuela. In April 2010, Venezuela agreed to order 10 Mi-28s for the Venezuelan army. But the contract may not have been signed. Variants. Mi-28, prototype version. First flight in 1982. Mi-28A, original production anti-tank helicopter. Development done in 1998, first flight in 2003. Mi-28 NMMW Havoc, all-weather day-night version. Equipped with a top-mounted millimeter-wave radar station, IRTV, and a laser rangefinder. Powered by two Russian Klimov TV3-117 VMASB-3 engines, produced by the Ukrainian motorcycle. Max takeoff weight 11,500 kg, max payload 2,350 kg. Mi-28D, simplified daylight operation version. Similar to Mi-28N, but without top-mounted radar and FLIR. Mi-28NA, export version offered to North Korea. Mi-40, proposed armed transport version. Never reached prototype stage. Mi-28UB, Waibno Bojavoj, training and combat, version, designed for training for Mi-28N. Has dual hydromechanical flight controls that can be operated from tandem cockpits, a more spacious lower cockpit to house a flight instructor, a wider pilot canopy, and new energy-absorbing crew seats. Serves as a trainer but can perform attack helicopter tasks. Operators, Iraq, Iraqi Air Force 23/30 Mi-28NE, a Kenya, Kenya Air Force 16 Mi-28, a Russia, Russian Air Force, 78 Mi-28N, specifications. Data from Janes, RIA Novosti, Russian helicopters, JSC, general characteristics, crew, 1 pilot, 1 navigator weapons operator, length, 17.91 meters, rotor diameter, 17.20 m, height, 3.82 m, disk area, 232.35 miles squared, empty weight, 7,890 kilograms, loaded weight, 10,500 kilograms, max takeoff weight, 11,700 kilograms, power plant, 2A, Klimov TV3-117/VK2500 turbo shaft, 1,636 kilowatts/ 1,985 kilowatts each, performance, maximum speed, 324 kilometers per hour, cruise speed, 265 kilometers per hour, range, 435 kilometers, combat radius, 200 km. With 10 minutes loiter and 5% reserves, ferry range, 1,105 kilometers, service ceiling, 4,950 m, rate of climb, 13.6 meters per second, hovering ceiling, 3,600 m, armament, guns, 1A, chin-mounted 30 mm Shipinod 2A42 cannon with 250 rounds, hardpoints, 2 pylons under each stub wing to mount bombs, rockets, missiles, and gun pods. Main armament configurations include 16 Aterka-V anti-tank missiles and 40 S-8 rockets, or 16 Aterka-V anti-tank missiles, and 10 S-13 rocket, or 16 Aterka-V anti-tank missiles, and 2 23 GSH-23L gun pods with 250 rounds each. Other ordnance, 9 K-118 Shexner and 9 A-2200 anti-tank missiles, 8 Igla V and Vimpula 73 air-to-air missiles, 2 kmg-U-2 mine dispensers. See also. Related development, Mi-24, aircraft of comparable role, configuration and era, Augusta A-129 Mangusta, AH-64 Apache, AH-1Z Viper, Denel Roy Valk, Eurocopter Tiger, HAL-like combat helicopter, Kamov Kar-50/Kar-52, TAI Egerstorsland T-129, WZ-10. References. The initial version of this article was based on material from Aviation.ru. It has been released under the GFDL by the copyright holder. Citations. Bibliography, Eden, Paul. The Encyclopedia of Modern Military Aircraft. London, UK, Amber Books, 2004. ISBN A1-904687-84-9. External links, Mi-28 page on army-technology.com, Mi-28 page on helis.com, Mi-28 on globalsecurity.org, airshow video on youtube.com.